You know about the 6 Mr. Cent forms of energy and can trace the transformations that occur within a system. We'll now explore the relationship between one of those forms, electrical energy and magnetism, and then further explore 2 devices that make use of that relationship. Read and highlight the introductory paragraphs, paying particular attention to the 3rd paragraph and its discussion of magnetic fields, electromagnets, mechanical and electrical energy. Complete the Before You Begin section at the top of Sheet 2. The first and final forms of Mr. Cent energy are given to you in the first introductory paragraph, but try to figure out what the in-between transformation might be. Part 1 of this lab has you perform various maneuvers with magnets and record your observations. Read the introductory paragraph for Part 1, then shift your attention to Step 1 of the directions and observations. I will read each step and perform the activity, stating any observations that are not visible. Begin with Step 1 at the bottom of Sheet 2. Pause the video after each step so that you can record your observations. Step 1. Put 2 magnets on a desktop and slowly move 2 similar poles towards each other. Pause the video here and record your observations. Step 2. Now slowly move the north and south poles toward each other. Again, record your observations. Step 3. Without allowing the magnets to actually touch, move one magnet in a way that causes the other magnet to spin. So by simply putting the like poles and repelling, it can cause the magnets to move. Step 4. A compass can detect a magnetic field. Gently slide a compass along the poles and the length of a magnet. Notice any fluctuations in the compass needle. Describe what happens as you move the compass from one end of the magnet to the other. What properties do magnets have that cause this to occur? Step 5. Move one of the magnets close to the paper clips and describe what happens. Step 6. Move the paper clip along the length of a nail that has never been exposed to electricity. What do you observe? Now turn to Sheet 4. We have the insulated wire coiled tightly around an iron nail and connected to an electricity source. There is current flowing because the circuit is complete. Move the compass along the length of the nail. Record your observations. Remember that this nail is now surrounded by electrical current, which was not the case in the step before this. Based on your observations, what can you infer about the effect of adding electric current to the wire? Going on to the next step, we're to place one end of the nail close to the paper clips and record our observations. First, how was this similar to what happened with the clips and the magnet? Second, based on this similarity, what can you infer? Third, What is the name of this device that you just made? And by that device, they mean a current carrying wire surrounding an iron core. Now the final step on sheet 5. Gently remove the iron nail from the center of the coil of wire. Notice it's still connected so that there's still current flowing through it. Move the compass along the length of the current carrying wire. You can see that there is just a tiny bit of magnetic effect on this compass, not nearly as great as when the iron core was in the middle of the coil, but still a trace of magnetic field simply with the current flowing through the wire.
What do you observe? What can you infer about electric current and the production of magnetic fields from this observation?